Hey everybody, a quick observation on this particular problem is to notice that n has to be less than 0. Right? Now n is an integer, but it has to be an integer that is less than 0, and that's simply because if n were positive, n squared minus n cubed would be negative, right? If n were a positive number, n minus n cubed would be greater than or equal to 0, n could be 1, right? But if, just because this n cubed outgrows n squared. So we know that our solution is going to have to be a negative value of n. Now, not surprisingly, factorization is going to help us out right here. So we factored an n squared out. And then this constant is pretty repugnant looking, but it certainly is divisible by 2. And also notice that 3 divides the sum of the digits. Let me write that down. 3 divides 1 plus 2 plus 6 plus 9 and plus 6 again. All right, and that's pretty well known. The proof's not too hard. It follows from the fact that 10 is congruent to 1 mod 3. But notice if you add this up, you get 1 plus 2 is 3, that's 3 and 6 is 9, 9 and 9 is 18, 18 and 6 is 24. So 3 divides 24. So this particular test, if an integer divides the sum of the digits, it divides the number itself, okay? So it does, this particular 5-digit integer is divisible by 2 and 3. Now, with a little bit of work, you can get this far with it. 2 divides into it 3 times. Okay, and again, you have to check that yourself. I won't go through all of that. Now, what do we have right here? And by the way, it doesn't pass the divisibility test for 5 or 7, which is a little more obscure, or 7 and 11. You can check for 11 yourself if you want to. There's an alternating test for that. But anyway, we at least got this far, which gets us to the point where we can divide 24, which is 2 cubed times 3. We can divide 24 into, and don't think I'm going to do this by hand, but this is at least what you would do, and this is achievable. And this is actually really the hardest part of the problem. Okay, and I'm going through it a little fast, but if you perform this long division, you'll end up with 529. Okay, and again, I don't think you want to see me do that. I probably would make a mistake, but that's 529 right there. Okay, when you divide 24 into this number, at least the last digit is correct, right? 4 times 9 is 36, so that's a necessary condition, not a sufficient condition for this to be correct. All right, so what we know is that this is equal to 2 cubed times 3. And y'all, guess what? Let's see. This guy right here is 529 is 23 squared. So we can put 23 squared right here also. All right. So again, more work than what I showed, but it's all doable. It just takes time. So the computation happens right here, finding the prime factorization. Now let's move along. And again, I have this recorded right down here. And notice that the answer follows fairly quickly. The natural trial, we've already concluded that n has to be less than 0, right? We've already concluded at the beginning of the video that n has to be less than 0. So it's natural to try. And you can just see it falls right out into place. You'll have minus 23 quantity squared times 1. And it's just kind of a fluke of the factoring, I think. Minus negative 23. Okay. Equals to 23 squared. Times 24. But you see, that's exactly what this is. And you see, we didn't have to do any, quote, big calculations down here because it all happened up here. Okay, so this part right here is 24, right? 2 cubed times 3 is 8 times 3, which is 24. And so it works out. We get minus 23 is the solution. N equals to minus 23. So again, I think this is pretty fascinating stuff because it shows you how vital the prime factorization is. See, we didn't have to know anything. We didn't have to know, right when we got to this stage, we didn't have to know that this number is equal to 12,696. Once we did the work to find the prime factorization, all of that, just the actual magnitude of this 5-digit number is gone. It evaporated. But again, you did pay a computational price right here. I didn't show you the steps here, but this is correct right here, 529. It's just a few steps to show that. Again, the finding the prime factorization is the big computation here. This part right here is close to trivial to look at this and look at this factorization and know to try minus 23 in light of the fact that n has to be less than 0. Okay, so n equals negative 23 is the solution.